Hello everyone, my name is Abhishek and welcome back to my channel. If Uber can implement zero downtime deployments, in the other words, if Uber can roll out new features of their application with absolute zero impact to the end users, why not banks? I'm sure you must have noticed your bank keeps sending you text messages or email notifications regarding maintenance windows. What does that mean? So the IT department of your bank is performing deployments during that particular time frame so that your bank servers will be down and your bank notifies you that during this window you cannot perform any transactions or during this window you cannot log into your bank. Now the big question is that in 2025, if Uber or your instant food delivery applications or applications that you use on day-to-day basis, if they can perform deployments with zero downtime, why not banks in 2025? Most of the banks actually schedule maintenance downtimes even today. There might be some banks, those banks are exception. But in today's video, let's try to understand what are the reasons. I will talk about 4 primary reasons in today's video, and all of these reasons will be from DevOps, cloud, and SRE point of view. Of course, there are reasons from development point of view as well, but I will be only talking from DevOps, cloud, and SRE point of view. This is going to be very, very insightful. Make sure you watch this video till the end. First reason, probably the most important one, monolithic architecture. What is monolithic architecture? In simple words, let's say you are writing an application and this application is written in 40,000 lines of code. If you write this 40,000 lines of code and this 40,000 lines of code is bundled into one single package, then it is called as a monolithic architecture. So if you are writing your application in Java programming language and end of the day, your 40,000 lines of code is bundled into a single WAR file, jar or EAR file, that is enterprise archive, then your application is told to be in monolithic architecture. What are the drawbacks of it? Why is it considered an anti-pattern for zero downtime deployments? Very simple. Imagine one of the developer has just want to update maybe footer. So developer wants to update a simple copyright license on the user interface of the bank application. This is a very, very simple change. Probably this will be updating 5 to 6 lines of code, but still entire 40,000 lines of code has to be deployed. Now deployment wouldn't take a lot of time, but still after deployment, QE has to perform business testing. Business testing is nothing but when you're dealing with bank applications or when you're dealing with financial applications. Once the application is deployed, before making the application live, sometimes even after making the application live, but most of the times, once the application is deployed and just before making it live, that is telling the users, everything is ready now, you can access it. QE engineers run something called business testing. In this business testing, they'll just verify through the user experience. They'll just log into the UI and they'll just verify if the user's experience is absolutely same as before or if the user's experience is seamless. Now, if 40,000 lines of code is deployed again, quite obviously QA engineer will not just verify the footer changes, but QA engineer has to run all the UI test cases or has to perform all the corner cases even when it comes to the user experience. So that's why post deployment and before making the application live, during this 30 minutes or 40 minutes maintenance time, business testing is run. These can be automated test cases. This can be run by the QA engineer, or these can be run by one of the bank employees, right? Who is in the IT side. So because of this reason, monolithic architecture is an anti-pattern. Now, if you go for microservice architecture, right? What happens? Like if you take the same example, in the microservice architecture, application is broken down into multiple microservices. As the name suggests, microservices, you are breaking the application into small parts. This does not depend on the lines of code. That is not like if you have 40,000 lines of code, every 1,000 lines of code is not broken down into a microservice, but this breakdown is performed on the functionality basis. So your architect decides that, okay, in this monolithic architecture application, login can be called as a microservice because this has a complete different functionality. This can be independently deployed, this can be independently tested, and this can be independently developed as well. Similarly, payments can be qualified as a microservice, transactions can be qualified as a microservice, shipment can be qualified as a microservice, notifications can be qualified as a microservice, because in future if notifications has to be updated, developers don't have to change the code related to login, payment, shipment. They'll just head to the notification. If this is written in Java, they'll update the notifications package and they will redeploy this particular microservice. Now, in this case, the downtime can come from 30 minutes, or maintenance window can come from 30 minutes to maybe 2 minutes, because once the application is completely deployed and before making the application live, so what DevOps engineers can simply do, so they can go to the servers. It can be Kubernetes cluster or it can be a virtual machine. They will head to the login service wherever it is deployed. They will just remove the login service. They'll redeploy the new version of the login service. Let's call it V2. And they will tell the QE that, okay, before I point the load balancer back or before I make this live, so just run the business tests. Business tests are not applicable for all the applications. These are typically for applications like banking applications. So now QE just has to run the workflow related to login. They will not take 40 minutes, but they'll just take 2 minutes because they just have to log in, log out, and run some test cases related to the user experience, right? And if this change is related to footer, developer can say, hey, I just updated footer and that is in this login application. So they can only focus on that particular part. Maximum impact would be on that 1,000 or 2,000 lines of code. Whereas here, impact is on 40,000 lines of code. So this is one of the main reasons why bank applications come with maintenance window. But Abhishek, in this case, you said maintenance window came down from 30 minutes to 2 minutes. But this is not zero downtime. Now we are talking about zero downtime. Just by changing application from monolithic to microservice does not make the deployment zero downtime. There are additional things which these banks have to employ, something like Canary model of deployment or Canary deployment strategy. What happens in Canary deployment strategy? Like, let's say version 1 of the application, or in this case, login application, has 2 copies, for example, or 2 replicas, V1, V1. And a load balancer is pointing to V1 and V1. In Canary model of deployment, now the same load balancer will be pointing to V1, V1, V2, V2. So V2 will also be deployed. Load balancer will be pointing to V2 as well. And you will tell this load balancer forward 90% of requests to V1 and only 5% of requests to V2. So this is called as ratio based load or ratio-based load balancing, or sometimes is also called as weight-based load balancing. Now, in this case, what happens? You can reach absolute zero downtime deployment because the load balancer is pointing to V1 and V2. So you can tell the load balancer, okay, initially point only 5% of traffic to V2. And these 5% can be your bank internal employees only. So during this time, QE can verify, right, by using V2 of the application. Within the load balancer, you can say which users have to get this V2. So you can say QE on the servers that they log in should access V2 of the application. So they will log in, they will run test cases on V2. They can take 2 hours, they can take 3 hours. It doesn't matter. Once they say, okay, V2 is absolutely fine, then DevOps engineers will change the weight from 95 to 5 to 50-50. And eventually they will make this 100 and they will make this 0. So just by changing application from monolithic architecture to microservice architecture does not lead to zero downtime, but a proper deployment strategy, something like Canary model of deployment, needs to be used. Now, the combination of monolithic architecture and deployment strategy can get you to zero downtime. Okay, are these only reasons? No. One of the very, very popular reasons why your banks get into maintenance windows, I'm not sure about all the banks, but I have specially seen some banks, they get into these maintenance windows quite frequently. And you might have seen some legacy applications, especially with lot of users, they get into maintenance windows quite often. Why? The reason is because they are not shipping features frequently. So when you go to their websites, you will not see a lot of fancy features. You will like they might get into a maintenance window for 30 minutes, or they might get into a maintenance window for 60 minutes. And even after the maintenance, you will not see any difference in the application. I'm sure you must have noticed it. Now, the problem is that they are not updating their application, but they were running database migrations. So database migrations is one of the reason why your banks quite often get into maintenance window. It's maybe they want to update new user details, or they want to run some batch processes. Maybe some users have changed their limit. Maybe some users, they want to mark some users as a privileged user, right? Or they want to update something to the database tables. They want to add new columns to the database for some reason. So it can be any internal reasons of the bank. Now, these things, they are not changes to the code, but they are changes to database. And when they run these database migrations, they don't use modern databases. Some things like, today you have modern databases like Liquibase, or you have Flyway database, where database migrations happen in a fly. So database migrations can actually happen with zero downtime. But unfortunately, because these are legacy systems, they might be using old Oracle database, old version of Oracle, or they might be using very old version of a database, which does not have these capabilities. Because of that, every time they want to run database migrations to update their user details, or maybe to update something in the databases, tables, they declare a downtime and they just run the database migrations. So they run few queries, and once the queries are updated, once everything is fine, they just say, okay, maintenance window can be removed, and you can declare that the application is live again. That's why sometimes you notice applications get into maintenance window, but there are no features added. There are absolutely zero changes to the application. Now, finally, the fourth one is feature flags. This is not very, very important, and this might not directly impact the downtime, but it adds a flexibility. So I thought I'll also talk about it. So again, this might not be directly related to downtime, but a flexibility is provided for the DevOps engineering team. and also flexibility is provided for QA engineering team. So in this approach, what developers do, so let's say there is an application, right? Again, let's consider monolithic application. So there is a configuration file that this monolithic application is reading internally. So developers create a JSON file which this application read, or they use a YAML file which this application read. And within this JSON file, they just say feature enabled, right? Only when they change the flag to feature enabled, or they tell the end users, hey user, just go to your bank application, and within your bank application, just go to settings. And once you go to settings, you will find a section called credit card. Within the credit card section, you will find detailed transaction summary. Only if you enable that checkbox, you will get the detailed transaction summary once in every month to your email box. Or only when you enable this checkbox, you can see this feature working. If you don't enable this checkbox, this feature will not be working. And this particular thing is called as feature flags. Now the advantage of the feature flags is that blast radius will be less. So what they are doing, this particular feature that they have added, maybe this can be of 1,000 lines of code, and this can be well integrated in the monolithic application. So if there is some issue with it, so the development team or the bank can directly say, hey, do not enable that checkbox. There is some issue with that checkbox. So once we are perfectly fine and once it is working again, we will just tell you that, okay, you can enable that checkbox again. That particular feature is working. Now, how can this reduce the downtime? Again, during the business testing, right? So let's say instead of directly releasing the features, if the feature is released with the feature flag, now QA can have some space that during the business testing, they don't want to cover all the corner cases, or even if something goes wrong, right? Even if they miss something during the business testing, no, they will be in a way that, okay, there is a feature flag for it. So if something goes wrong, we can tell the end users, disable that checkbox. It's not a mandatory thing, or it's a beta feature. It comes with your risk. So the testing time can be reduced once the application is live. So again, 30 minutes downtime can be reduced to maybe 15 minutes. So feature flags are a way where you can reduce the downtime. So these are some of the patterns using which downtime can be significantly reduced. And by employing microservice architecture with a proper deployment strategy like Canary model of deployment, they can actually get the downtime to zero. However, because these are legacy systems, because these are systems where making changes are very difficult, sometimes the code base is there from last 20 years, 30 years. So even the new developers are worried if they can break the monolithic architecture into microservice architecture. So this is one of the reasons why over the years, banks keep coming with the downtime or the maintenance window. Of course, some of the banks have started using a blue-green model of deployment for the last 4 years, 5 years. Because of that, the downtime came from 5 hours, 6 hours to 30 minutes. Because with blue-green deployment strategy, banks have a lot of money. So they just create carbon copy of their server and they point the load balancer to the new server, or they point the new load balancer to the new infrastructure. I hope this video is informative and I hope you learned something from this video. You have something to take back. Let me know in the comment section, how did you find this video? And let me know if you learned something new today. See you all in the next one. Take care, everyone. Bye-bye.